class, and welcome to lesson 2.1 on decimals and fractions. So the first thing that we need to look at is we need to look at place values. In order to understand how to go from decimals to fractions, we need to understand how place values work. So what do we notice? Do we notice any patterns here with our place values? Do we notice anything that's happening?
So the whole part is this sort of similar to the decimal part because you're just adding to the end.
Yeah, exactly. So here we've got our ones place and our decimals place. Excellent. So we start like that. But then if you notice, we've got tenths, tens, hundredths, hundreds, thousandths, thousands. So we're just following that same thing, going in opposite directions. What is the difference? How can we identify the difference between when it's a whole part or when it's a decimal part, Lennox?
We can tell because the decimal point is technically 1. So the tens, hundreds, thousands is less than 1.
That is true. Lior, though, how can I tell, like, just by reading it, what is something that I can tell? How can I tell what I'm talking about?
That the decimal part, it has a TH instead of just an S.
Excellent. So we see here that for our decimals, they've got that TH as opposed to our wholes that have just that S. But they still go in that same direction. So just splitting out each side, they go in that same direction. So we see that tenths, we see all of that. So let's look at this, okay? Thinking about our place values, who knows how I could write 0.25 in word form? Nathan?
Would it be 25 hundredths?
Yes. So it'd be 25 hundredths. Nathan, how did you know that? How'd you know that, Nathan?
Because on the chart, the first thing closest to the decimal was tenths, then it went to hundredths, and then the last number is on the hundredths line.
Oh, he got it exactly what I wanted to hear. So here, this is our ones. That's our tenths. This is our thousandths. The furthest one right, the furthest one to the right is what I care about. So as we would see, for the further ones, because I don't feel like doing it, I'm going to copy and paste. There's that one. Here's this one. And here's this one. It's going to be that same thing. For the percussion, it's going to be 15 hundredths. Here it's going to be 31 hundredths, and here it's going to be 29 hundredths. All of those because the furthest number to the right is in the hundredths place. And then to write it as a fraction, here's how it works. Since it's a hundredth, I put it over 100. So what would I put at the top of that one, Lennox?
You would put 25.
Perfect. 25. 20. Same with the other ones. We put that 15 hundredths. That's what it means. We put that 31 hundredths. That's what that means. We put this 29 hundredths. That's what it means. So in our place value, we just put the exact number over the furthest right place value. So that's just how we start this, though. That's just how we start this. That doesn't mean that's going to be the very end of it, though. Why isn't this the very end? What could I do? So, Lennox, you were going to say it earlier. What could I do?
You could simplify it.
Yeah, I can simplify. What does this one simplify to first, Lennox? The 25 hundredths.
The 25 hundredths is equal to 1/4 because if you know that 25 plus 25 equals 50, then 50 plus 50 equals 100. And then if you divide that by 20,
He's going the complicated route, but we know that quarters are worth 25 cents and there are 4 quarters in a dollar. Their greatest common factor is 25. Jack, what is the simplified version of 15 over 100? Do you know?
3/20?
Yes, 3/20. Their greatest common factor was 5. Can I simplify 31/100ths? Yes or no? What do we think? No, I can't simplify it. I think 31's prime. Can I simplify 29/100ths? No, again, I think 29's prime. Don't take my word for it, but they look like prime numbers to me, and I'm typically good at that. So sometimes we can simplify these things. So I just want you to look at this. Decimals like 0.25, 25/100ths, 0.15, 15/100ths, 0.31, 31/100ths, and 0.29, 29/100ths can be written as fractions with denominators of 10, 100,000, and so on. Any number that can be written as a fraction is a rational number. So here I've got this thing right here, rational numbers. We've got all sorts of numbers. We don't have to worry about irrational numbers right now. Rational numbers just mean I can write them as a fraction. If I can write it as a fraction, it works. Integers are a whole number. What that means, though, is that they have to be, they're not a fraction. They don't have a decimal. It is 1, 2, 3, 4. It is all of that. But it's also the negatives are integers. Whole numbers are only positive numbers. Whole numbers are positive integers. And then we have something even more that's called natural numbers, and natural numbers are all whole numbers but 0. Natural numbers are all whole numbers but 0. So like I said, a rational number is any number that can be written as a fraction. If I can write it as a fraction at all, then it is a rational number. So for example, 0.25. I was able to write that as 25/100, which also simplified to 1/4. If I had something like this, 0.825, I'm able to write that as 825 over, and who can tell me what the denominator would be? What is it, Lennox?
1,000.
1,000, because this is in the thousandths place, the furthest right. Exactly. And then again, I could simplify it. And I believe that it simplifies to 7/8. I may be wrong here, but I believe that it does. Don't take my word for it. So we see all of this. We see all of that. These are what rational numbers are. All you need to know about a rational number is that they're numbers that can just be written as fractions. So rational numbers, by the way, rational numbers include integers, include whole numbers, and include natural numbers, which I said aren't on here, but natural numbers are all positive whole numbers except 0. But rational numbers are basically any number. I can write the number 1 as a fraction. I can write the number 1 as a fraction as 1/1. I can write the number 1,000 as a fraction as 1,000/1. Anything that can be written as a fraction is a rational number. Here's the thing. To go from a decimal to a fraction, you put the number over the furthest place value to the right. So just like what we saw earlier, just like what Nathan said, what everyone said, you put the number over the furthest place value to the right. So that's how we go from decimals to fractions. So for example, I want you in your notebooks to do this. Write each decimal as a fraction in simplest form. So just like what we did earlier, write each decimal as a fraction in simplest form. So Marquis, what is our initial fraction for 0.6?
6/10.
Perfect, 6/10. Excellent, Marquis, because it's in the 10th place. Great job. Anna Jolene, what is the simplified version of this?
3/5.
3/5. Exactly. We divided by their greatest common factor, which was 2. Damar, what is the initial fraction for 0.45?
For 0.45, it is 45/100.
Excellent, because the furthest right place value is in the hundredths. And Jack, what is the simplified version of this?
9/20.
Perfect, 9/20. We simplified by their greatest common factor, which is 5. Literally, that's how we do this. We just think about the furthest place value to the right, and then we simplify, just like what we did with the last chapter. These are equivalent ratios, you guys. Remember what we did? Ratios are fractions. They're equivalent ratios. They're equivalent fractions. They're all the same thing. So we're all good here. What about these ones? So I want you to look at these ones.
The initial fraction is
Perfect. Our initial fraction is 8 over 10. And then, Brody, what is our simplified fraction for this one?
4 over 5.
Perfect. 4 over 5. Their greatest common factor was 2, and they're both even, so we don't even need to worry about it all of that much. So Samantha said it is 375 over 1,000. And Nick, what's the simplified version?
37 over 250.
Ooh, we're kind of close. This one's hard. This one's big, it's hard. I know that they're both so far divisible by 25. That's the first thing that comes to my head. So I divided them both by 25. 375, when I divide it by 25, I get 15. And then 1,000 divided by 25, I get 40. So based on that one, I'm going to have you simplify that one, Nick, okay?
It is 5 over 8.
Ooh, you're so close. It is 3 over 8. You divided by 5 on both sides, which is why you said 5 over 8. So yes, their greatest common factor is 5. 15 divided by 5 is 3. 40 divided by 5 is 8. So we get this to be our simplified fraction. So when we're doing this, that's how we simplify our fractions. We initially put it over the furthest place value to the right, and then we simplify. One more set here. Perfect. It is 28 over 100. This furthest place value is in the hundredths place. So all I do is I put it over 100. What's my simplified version, Ben? Perfect. So our simplified is 7 over 25. We found out our greatest common factor is 4. So, Oslin, what is the initial fraction for 0.125?
I got 125 over 1,000.
Perfect. 125 over 1,000. Excellent. And then, Alex, what is the simplified version of that?
So, to simplify it, I used 25, so I divided them both by 25, and I got 5/40.
So we got 5/40. Can we get it even smaller? Lennox?
We could do 1/8.
Perfect. 1/8, because they also share greatest common factor. However, like I said, divide by what you can. He divided by 25. That's what he saw. Awesome. There's no problem with that. We just check. Did we look at it and we say, okay, can we make it any smaller? And we just keep trying. So exactly, you guys are doing so well. So what's our initial?
9.85 1,000.
So he says 9.85 over 1,000. That's a good guess. It's a good guess. We're getting closer. Marquis, do you know what it is?
It's 9 holes and 8,500.
Yeah, 9 holes and 8,500. So, exactly, we were seeing something very similar. So it's 9 holes and 8,500. Technically, that is written, we can write it as 985 over 100. But we don't want to do all of that hard work, so we just keep this number in the front. We just keep that number in the front. Based on that, what would the initial fraction for the next one be, Kevin?
4 holes and 65 over 100.
Excellent. Perfect job. And then I want, let's see, Miles, can you simplify 9 and 8,500 for me?
I didn't think 18 over 25.
So Angeline said, well, I only managed to get the simplified version for 85 over 100. And she found out that it's 17 over, and we divided it technically by 5, so 17 over 20. Hey, guess what? We just keep that 9 right in front. That's it. The 9 doesn't change. Leor, what is the simplified version for 4 and 6,500?
I'm not sure.
Leor says for the same thing, we just put that 4 in the front and we keep it. Nathan, do you happen to know what it is? Jack.
Is it 13/20?
It is 13/20. Same thing like I did. I just looked and I thought, hey, they both are divisible by 5. I got down and I realized, hey, I can't go any further than that, so we're good. Here's this. Take this down in your notes. This is how we go from fractions to decimals. Way number 1. is you can do the ratio table to try to get a denominator of 10, 100, 1,000. So we can try that ratio table. Way number 2 is to long divide. The best way is way number 2. Way number 2 will always work. Way number 1 doesn't always work, because as we know with our ratio tables, sometimes we ended up with fractions and that made our lives a little bit difficult. Way number 2 always works. So let's look at this. We're going to write each fraction as a decimal. I'm going to show you both ways because this one works with both ways. So for the first part, I want to get it over 10 or over 100, over stuff like that. I'm going to see if I can make that work. I don't know if it's a double jump or not, but I always make it just in case. Do these two numbers share any factors? Do 12 and 100 share any factors? Do they share anything? They do share something. What do they share? They do share a factor. What do they share? Brody, what do they share?
The factor they share is 2.
They do share 2. There's a bigger factor they share. Anna Jolene, do you know it?
Is it 4?
It is 4. So to go from 12 to 4, we divide by 3. To go from 4 to 100, we multiply by 25. Here I divide by 3. I get 3. I multiply by 25. I get 75. But how would I write that as a decimal? What would that look like as a decimal, Lennox?
It would be 0.75.
Perfect. 0.75, or as we see it here, 75 hundredths. That's not the only way that we can do this one, though. We can also do it with long division. But here's what we need to know about long division. Which number goes inside the house? You guys, which number goes inside the house? Of these two numbers. Nathan, do you know?
9.
9 goes in the house and 12 goes outside of the house. Your teachers in elementary school said this thing that upsets me very much. They said the bigger number goes inside the house. No! Not true. Not true. Let's look at this here. This will be very helpful. There are the 3 ways to see this, so write these down, okay? So we see this. We've got the dividend, divisor, and quotient. These are our 3 pieces. This is how they look in all 3 different ways that you would see them. Let's go back to this one. 12 into 9. So the first thing that we think about, 9 twelfths. Is 9 twelfths more than 1 or less than 1? 9 twelfths more than 1 or less than 1? Who can answer? Leor, what is it? Less than 1. Which is going to make sense because, are you ready? How many times does 12 go into 9? Show me on your fingers. 12 go into 9. It goes in 0 times because 0 is less than 1. What do I do now? So my answer is 0, right? Like I can't go any further, right? My answer is 0. Like my answer 12 or 9 divided by 12 is 0. Brody, what do I do?
After you do that, don't you have to multiply the 0 into 12?
You're kind of close.
Or
Well,
no, 0 into 9?
You're decently close. We're seeing this. All I do, I'm going to add a decimal and put another 0. Is 9 different than 9.0? Are they different? No, those are the exact same number. And I could put more zeros, however many zeros, it doesn't matter. How many times now does 12 go into 90? How many times does 12 go into 90? So think about that.
8 times.
It does not go into 8 times. We're really close. Do we know, Jack?
Yeah, it goes in 7 times.
7 times. And what is it? When it's 7 times, it's?
It's 84.
84. Excellent. We do our subtraction. 6. I bring down, I put another 0 and I bring it down, right? By the way, do you see how I've made a decimal there? I'm going to put that same decimal, bring it just straight up. Just bring it straight up there. How many times does 12 go into 60? Who can tell me how many times 12 goes into 60? Leor?
5.
5 times. And it is exactly 60. So we end up, we got our 0. Awesome, you guys. We finished. We find out that it is 75.75. That's the same thing we got last time, right? Yeah. So there's two different ways we can do it. The long division will always work. So we're going to do these problems. We're going to go over it together. They happen to be able to be done with the ratio table, just like I'm able to see. But if you're not able to see it, just long divide, always. Our initial fraction here is 3/5. Initial fraction here is 14/25. Our initial fraction here is 102 250ths. So we can ratio table it. We want to get this part here to either be a multiple of 10. So 10, 100, 1,000, 10,000, whatever it is. We want it to be like that. So you're going to want to get to the closest one. Who wants to tell me how to solve the first with the ratio table? Emma?
So what I did was I looked at the 5, and you have to multiply by 2.
So she multiplied by 2 to get that base 10. So she got 6/10, right? 6/10. And what is that as a decimal then, Emma?
0.6.
Perfect, 0.6. That's our 10th place. Excellent. What about the second one as a ratio table? Who did the second one as a ratio table? Who can tell me? So here we can ratio table this to get base 100, and here we can get base 1,000. Notice that we're just doing single hops here. So Jack, to get from 25 to 100, I multiply by 4. What do I multiply when I get 14 times 4? What do I get?
Oh, sorry. I raised my hand because I thought you were talking about the long division.
Oh, that's okay. We'll do that one in a second. Great job. As I'm saying, I'm just going to skip ahead. 14 times 4, if we know it, we get 56. 56 over 100, all it is 0.56. Next one, from 250 to 1,000, it's times 4. So this one times 4 gives me 408. So I get 0.48. That's the ratio table way. Ratio tables don't always work, though. Ratio tables don't always work, though. So sometimes we gotta long divide. In this case, put the 3 here and the 5 here. What did you get when we long divided this first one, Jack?
Here, let me check my notes. I got. Where are my? Okay. Do you mind if I can do the second? I totally.
Jack, what's the second one then? So what's the second one?
Okay, sorry. The second one is 0.56.
Perfect.
56
5600ths. We found out it goes in 0 times to 14, but when I add my decimal, it goes in 5 times. We get 125. I subtract, I get 15. I bring down another 0. And 25 goes into 156 times, and that's exactly 150, and I'm done. What about this first one? What about
I
this?
did find my word for the first one.
Brody, what about the first one?
The answer I got for the first one was 0.6.
Perfect.
6/10.
Perfect. 0.6 or 6/10. 5 goes into 3 0 times. We put that decimal, add the 0. 5 goes into 36 times. It's exactly 30. We get 0. We're done. What about this last one then? We already know, because the top is smaller, we already know that we're going to be starting with a 0. I'm just putting the 0 over it, pretend that it looks a little bit better. I'm going to add that 0 right there. How many times does 250 go into 1,020, Lior?
0.48.
Perfect. So she says it's 0.48. She's correct because it goes in 4 times initially. That's 1,000. I subtract, I get 20. I bring down another 0. Here, isn't that what I do? So here's the problem like we had. I was blindly trusting, but that's okay. It's 408 because 200, it doesn't go in. I got to make it a 2,000. And then that goes in 8 times. So we see that this one got a little bit crumpled. It got cramped. But we find out here we had 102, 250, goes in 0 times. Here it goes in 4 times. That's 1,000. We get 20. We bring down there. It goes in 0 times. We bring down another 0. 2,000. We get 8 times. Long division works. So the other way works sometimes. Like I said, we did all of these with our proportions of 10. So the first way was long division. This second way, we did it like this. That's how we did it. We need them to have a base 10. It can't be 20, it can't be 30, it can't be that. We need to have base 10s. If they are mixed numbers, you guys, you just keep the big number, aka the integer, and only divide the fraction. That's it. So that big number stays. We only need to long divide the fraction. In this case, I made one we didn't have to long divide. This is 1/10. This is 1/10. So when they're mixed numbers, we just keep that mixed number, just like what we saw earlier. Guided practice on page 92. So let's look at that together. Guided practice on page 92. Jolene, what is it as number 1?
The simplest form is 2/5.
Perfect. 2/5. That's a little light, so I'm going to fix it. 2/5. We found out that it is 4/10, and we simplified. What about this next one, Brody? What is the next one?
So it's the simplest form, right?
Yes, simplest form.
The next one is, wait, let me do quick.
Wait, Lennox, what's 3?
2.75 is equal to 2 3/4.
Perfect. 2 3/4. It was 2 75/100. We simplified. Excellent. So for that number 3, do you got it yet, Brody? Perfect, Brody. We get 16/25. It was 64/100, and then we just divide. Over here, Jack, what do you get as this first one, as our decimal?
So I got 0.324 or 324,000.
Ooh, we're really close here. It's actually 0.36. I think you had a little bit of a math calculation.
I must have.
Yeah, don't worry. I see what you were getting. So again, we just do the long division. We put the 75. We put the 75 on the outside, and we put the. Oh no, I was right the first time. Wait, no, I'm not. And we put the 27 on the inside. We know it's a 0. We just start continuing. 3. That's all of that stuff. Same thing here. Number 5. Who wants to answer number 5? Number 5.
Of course.
Jack, what'd you get for 5?
I got 3 5/10.
3 5/10. Perfect. 3.5. All we did, we found out. First of all, we know 7, or in here, 2 goes into 7. It goes in 3 times. That's 6. We subtract, we get 1 decimal. Bring down our 0. 2 goes into 10 5 times. 3 5/10. What about the last one? Can anybody answer the last one, Harry?
I was actually a little confused.
So we get
I can explain it to Harry if he's a little.
we get 3.2. We keep this big number. We don't even care. We don't need to do this. 1/5. I'm going to divide it. 5 goes into 1. 0 times. I make it a 10. It goes in 2 times. That's exactly 10. I get a 0. So we see things like that. We see our factors like that. These last two, Mr. Ravenhead's car averages 23.75 miles of gasoline, or express it as a mixed number. We get to keep that 23. 75/100. We simplify that, Jack.
I also did this one as well.
What?
And I got 25 3/4.
Perfect. 23 3/4. This other one, a Siberian tiger, can grow up to 10.5 feet long. Express it as a decimal. We get to keep that 10 because it's our integer. It doesn't matter. Our big number always stays the same. And 4/5. 4/5 as a decimal. I'm going to call on, who do we think? Jack?
It is 10.8.
Perfect. 10 8/10. Excellent. Because we get 4 divided by 5, we'd get 0.8. Or we can make it over 10 and get 8/10, just like our ratio tables. This is 8/10. So that's how we do these problems. Do the long division if the ratio tables don't make sense to you. Do the long division. Here is the homework. It is going to be page 93 evens. Then there are 2 challenge problems if you want them. They're good. They're numbers 9 and 11. These are the challenge problems. I enjoy them. I just wanted to give you guys the option, but I want you to do the evens on just page 93. Just page 93, not page 94, just page 93.